So example 3. Show that f and g are inverses, where here's the f and the g. So how are we going to show? We're going to take the composition and see if everything cancels and leaves us with x. So let's do the f of g of x first. Right? F of g of x. Right? First step would be replace the inner function with what it equals. So I'm going to replace g of x with this. The third root of x plus 1 over 2. And then do what the outer function says, right? The outer function, you got to plug into this. 2 times. Okay, now in place of the x, we got to put this whole thing right there. So this is the third root of x plus 1 over 2. And then in the f function, it's still got a minus 1. And that's all raised to the third power. So just replace the x here with this whole thing. And now simplify. What do you get when you cube a cubed root? They cancel each other out, right? So what we're left with from this line is 2 times x plus 1 over 2 minus 1. And now the 2's cancel, right? You're multiplying by 2 in this term, and you're dividing by 2, so that is x plus 1 minus 1, which is x, which was 1/2 of what we had to show, right? We have to show that f of g of x and g of f of x reduced to the variable x, and that one did. Now we'll do the other one, right? G of f of x is g of 2x to the third minus 1. All right. So now we got to do the g function. In the place of x here, we got to put that. So this is the third root of 2x to the third minus 1 plus 1 divided by 2. Do you see where I plugged that in? Okay, now in the numerator, negative 1 plus 1 cancel. So this is the third root of 2x to the third over 2. And now the 2's cancel, so it's the third root of x to the third, which is x. So in both cases, when we take the composition, we got x. So these are inverses. That's how you show. So they are, because these both equal x, they are inverses.